Hello, welcome to another lecture in our series on carboxylic acid derivatives. In the previous views, we talked about different carboxylic acid derivatives and some of the reactions we can do. Today, let's look at the carboxylic acid and the type of reactions we can do with a carboxylic acid specifically, right? So already we talked a little bit this idea that when we have our carboxylic acid, already this group's not a very good leaving group, right? That was part of the problem. This group's not a very good leaving group. So there's not a lot of reactions we can do, right? Not like we saw with the acid chloride, and moving on to the ester, we can do a little more reactions. As we get to the carboxylic acid, there isn't going to be as many reactions available for us, right? So in this case here, with our carboxylic acid, we're going to look at one reaction, which might look very familiar to some of you, right? Where I can take an alcohol under acidic conditions, right? If I take this alcohol reacted under acidic conditions, what can I do? I can convert this OH group into that group there. We'll call it R1, right? So I can take this group here and I can add it onto this carbonyl shown here and do a substitution reaction, right? But it's acid catalyzed reaction, right? And so if we think about this in terms of acid catalyzed, we can think about already about what will be the first step for this reaction. Now, when we talk about being acid catalyzed, we'll just go ahead and draw it like this, since we have acid in solution. We'll just assume we had a strong acid, it protonated the alcohol to start with, right? Not a big deal. Again, just to show that acid came from somewhere. And what do you think is going to be our first step here? What's going to happen first? Like we saw before, we're going to see protonation of our carbonyl. All right, we protonated our carbonyl. What's going to happen next? What do you think is going to happen? Just like we saw before, oxygen doesn't want to be positively charged. Electron's going to move up, right? This looks kind of familiar. I think you've seen this before, right? You've seen this story. Okay. Now we have that positive charge there, right? Oxygens, both oxygens are neutral, but we have this positive charge on this carbon here. What do you want to attack it with? Just like we have in here, we have our alcohol. And we'll call it R1, right? Signifying our alcohol. Again, remember, we need that carbocation to be there before our weak nucleophile, such as alcohol, can attack. Now it can attack. And I'm going to follow the sign right here. All right. Now we get to this species here. Notice all these oxygens in here. We've got 3 oxygens on here. Too many oxygens on that carbon, right? We want to get to back to the carbonyl, so something's got to happen, right? Again, what did we do before? We did our proton transfer, right? Just like we saw before, we end up doing a proton transfer, moves from one group to another. Once we've done our proton transfer, what's going to happen now? This group's going to what? It's going to leave, right? This group's going to leave. Now we get to the species here, right? We get this oxygen here attached to R1. Back to that carbocation. But we're okay now with this carbocation because we can do what our old friend, right? This will take care of this, like that. Again, this reaction and this mechanism should be very familiar, right? Very familiar. It's nothing we haven't really seen before, right? Carbocation. Now we have positive charge in the oxygen, and the last step's going to be what? It's going to be deprotonation. Right? Then we end up with our ester at the end here, right? So we end up with our ester. Again, notice I used water to pull off that proton. Necessarily, I could have used the alcohol to pull off the proton. Maybe we had H2SO4 in there, the conjugate base. We just know that proton's going to leave. It's not necessarily important which pulls it off because you know we have a little bit of alcohol, water, and our acid in solution, right? We just want to make sure we pull off the proton to drink this. This is the important part that we made this compound, that we know that we're going to be resonance and pull off that hydrogen, right? So again, this step is very familiar, this mechanism is very familiar with what we've seen before. In terms of carbonyl gets protonated, electrons move up, carbocation gets attacked, proton transfer, good leave group, leaves, resonance, and then now we pull out this proton, right? Again, you can see these steps over and over again, the same type of steps, right? Protonation, resonance, attack, right? Proton transfer, okay? Group leaves, resonance, things like this, okay? Back and forth. So a lot of these steps are very, very familiar to you. Should be very familiar. You should get very familiar with this, right? Shouldn't be too bad. Okay, so this is our reaction of carboxylic acid with our alcohol under stick conditions to give us our ester, right? Carboxylic acid to ester. In previous lecture, we talked about going from an ester to that carboxylic acid. We're just adding acid in there and our water in there, right? Very similar mechanisms both ways, right? There's one other reaction we'll talk about with our carboxylic acids today. So there's this. So another reaction I can do is I can take my carboxylic acid and I can react it with lithium hydride. And then the second step is going to be H3O+. Okay, so I can react my carboxylic acid with lithium hydride and H3O+. And the second step is going to give me what? It's going to form our alcohol, not a primary alcohol, right? And again, we saw this very similar, right? We know lithium hydride is a very strong reducing agent, right? It's very reactive. And so it's going to react with a carboxylic acid to give us this primary alcohol, okay? So we're not going to really go over the mechanism for this reaction. We just want to know that we can take lithium hydride and we can then react it with our carboxylic acid to give us a primary alcohol, right? We have to use a strong reducing agent, lithium hydride. We cannot use sodium borohydride. It has to be lithium hydride for this reaction to occur, okay? So carboxylic acid with lithium hydride to give me my alcohol, primary alcohol, okay? So those are really the two main reactions we can do with our carboxylic acids that we're going to go over today, right? As we move forward, as we noticed, we go to different leaving groups. We go to the amide leaving groups. We'll see that we won't, again, have as many reactions. Okay? So just keep track of all these reactions and kind of keep them all together so that we can use them for synthesis and other purposes, right? All these mechanisms are very similar. Mechanisms aren't too bad, right? Just recall the reactions, okay? Recall these reactions, product, reactants, right? Star materials, reactants, products.